Hello everyone. We are at phase 3, chapter complex number, exercise 1. And right now we are at question number 13. So let's go through the question. Question is 2 plus root 3. Okay, there is a small correction here. This is root 3. So 2 plus root 3i is the vertex of a square inscribed in the circle z minus 1 mod is equal to 2. All right, it's a good question. First of all, let us go through the geometry that is given here. Z minus 1 is equal to 2. From our concept of complex number, we know that the locus of complex number here is going to be a circle whose center is 1, 1, 0, that is on x-axis. And the radius is going to be 2. And if we were to have a square inscribed with a circle, one of the vertices is 2 root 3i. Okay, 2 root 3i. And then we have to find, just for convenience, let's look at the figure that is already there. So the center is at 1, 0, the radii are 2, and one of the point of the is 2 root 3. So let's call it Z1. And if it is having another Z2, then Z3 and Z4. Okay. Let's just suppose these are the 4 vertices of the square inside it. Okay, so this question can be solved in, I believe, in many ways. We can just go through the geometry also, because now we know that if this is the diagonal of the square is twice the radii or is equal to the diameter, which is in this case is 4 here. So we will come to know the sides of the square. I like to solve it just pure complex number so that we know how to deal with questions later on. First thing first, Z3. We can find Z3 by also applying midpoint formula here. We know that 1, 0 is the midpoint of 2 root 3 and something here. So we know from our coordinate geometry how to find out. We have been doing that for far too long now. But I want to introduce the concept of rotation here. Let's look at this. Let's call this at Z0, and just for now, treat it as a vector. Meaning what I'm talking about is Z0, and here we have Z1, this vector, Z0, Z1. How will we write it? So this is Z1 minus Z0. Z1 minus Z0. Now, if this Z1, Z0, not, yeah, Z1 minus Z0. So if this vector is rotated by 90 degree, we know the property of square. The other diagonal is inclined at 90 degree with the first diagonal. So if we rotate it by 90 degree, we reach Z2. If we rotate it by minus 90 degree, we come to Z4. Or if we rotate it by 180 degree, we come to Z3. So just by rotation, we can find all the vertices. So just let's go through it. So Z1 minus Z0. So let's first write this one. This is 2 plus root 3i minus 1. So this is nothing but 1 plus root 3i, correct? Now if this is rotated by I, that is anticlockwise 90 degree, then we reach Z3 minus Z0. This is nothing but this Z3. Where are we reaching? We are reaching at, oh sorry, not Z3, Z2. So where are we reaching? Z2 minus Z0, isn't it? Z2 minus Z0 is Z1 minus Z0 EI pi by 2. I have rotated by 90 degree, which is nothing but 1 plus root 3i into I. When we rotate by 90 degree, I. So what is it? Minus root 3 plus I, minus root 3 plus I. So from here, what is Z2? Z2 is equal to Z1, Z0 is nothing but 1. So what is Z2? 1 minus root 3, 1 minus root 3 plus I. So we get the coordinates of Z. 1 minus root 3 plus I. Now I want to get to Z4. I want to get to Z4. I want to get to Z4. How do I get Z4? So Z4 minus Z0. Z4 minus Z0. Z4 minus Z0 is nothing but Z1 minus Z0 rotated by minus pi by 2. What does that mean? That means 1 plus root 3i is multiplied with minus I, because that's what happens. So this is nothing but minus root 3, so plus root 3 and then minus I and minus I. So now we can get the coordinates of Z4 from here, because we know Z0 is 1. So Z4 is equal to 1 plus root 3 minus I. 1 plus root 3 and minus. So this is how we can get Z4, we can get Z2 here. And how do we get Z3? Z3 is the easiest one. We can use midpoint formula or just multiply with minus 1 here. I think Z3 minus Z0 is nothing but Z1 minus Z0 into minus 1, because we are multiplying with 180 degree. So whatever, it was just the opposite. 2 plus root 3 and we multiply with, yeah. So what did we get here? Here, 1 plus root 3i is multiplied with minus 1. Okay. 1. So 2 plus root 3i, 1 minus. So this is multiplied with 180 degrees e to the power minus 1. Okay. So this is minus 1 minus root 3i, and this is Z3 minus 1. So yes, this is nothing but Z3 is here minus root 3. So just by rotation, we can reach to all. The reason I use the rotation here, so that we know how to write the coordinates when they are rotated by a certain degree. But Z3 could also be found simply by midpoint formulas. I think that's about it. Thank you.